Okay, so hello everybody. My name is Agata Skorupka, and today I will speak to you about my journey towards CI/CD. I'm very excited to be here. It's my first tech talk, and I hope you will enjoy as much as I will do. And at the beginning, few words about myself. My name is Agata, as I already told, and I work as a cloud consultant for the Scale Factory. And if you don't know us, we are AWS DevOps consultancy, and we are passionate about scaling. So especially if you run SaaS business in the cloud, feel free to check our webpage and book a free initial chat. On the side, I am AI researcher, but in the past, actually, I have done many things because before I learned that it's DevOps what floats my boat the most. And actually, there is a reason behind why I'm sharing this with you. Connected to the talk, so bear with me. First, I graduated from law, which I didn't really like. So I graduated from economics as well, which was a little bit better. And I landed myself a first job as an economist, and I was involved into some statistical modeling. That was my first encounter with coding, and it was fun. So I decided to build a little dashboard around one of my data science models and show it to my team of economists. And they really liked it. They decided to add more and more features there. So what was a little statistical model at the beginning later turned out to be a little application, and later not so little application. My team eventually decided to show and sell to our clients. And there is one caveat behind that. I didn't have any experience with coding before, and also my team was an economist team. So I did not have really anybody to ask for help. That is why I did lots of Googling, and right now I know that is how you learn IT. But that means that you will learn a lot of mistakes on your way, and you will learn everything the hard way. That is why I like to think about that adventure as my personal Phoenix project, and I will share it with you today. Of course, it will be connected to CI/CD as it is the topic of my talk. And at the beginning, I planned to put a definition of CI/CD here to start, but I didn't really like this encyclopedic style. And the second reason is that that's not how I learned. I didn't start with theory and principles. I just went straight into learning by doing, which is, I believe, more natural way of learning things. That is how we as kids are learning life, just by mistakes, the hard way. And in that way, actual tools and practices, what CI/CD is, for example, turn out to have their own meaning and be solutions to real life problems, rather than boring theory and content at the beginning. And then it all makes more sense. That's why I want to share that with you. And that is why I think people read, for example, Phoenix project that much, because we like to understand the rationale behind tools and generally practices. So if I didn't mention, you probably know what CI/CD is. It's continuous integration and continuous deployment or delivery. But for the purpose of this talk, I would like you to forget for a moment that you already know what that is and join this, experimental journey with me. And for those who are worried that it will be too much, personal or speaking about just real life world problems, at the end I prepared a little demo, technical one, and I hope it will be interesting. So what is the first stop on our journey I would like to take you to? So I had my statistical model, and it turned out to be a little application. I shipped more and more features. Everything seemed to work fine. But the problem was, as I was learning everything by myself, at the beginning I didn't even have version control system, which means the only reason it was working and nobody seen that it was actually not very robust solution was the fact that I was working on this project on my own. And the testing was a nightmare. But shipping of new features and deployments were kind of efficient because of only one person behind that project. I could adapt waterfall approach, let's say, just one by one. And also because I was one-man army, that means there were no conflicts in the code or in the team. But is it really an optimal solution? Actually, this kind of setup even though it may seem efficient, it creates a very dangerous risk of being dependent on only one person. So what if that person, for example, falls ill, decides to leave a job, or life happens? This kind of setup, especially initial stages of some application, usually means there is no documentation as well. So you basically would be blocked if the one-man army would just disappear. On the other hand, one person means no tensions in the team. However, it also means, okay, you can learn by Googling, but there is a limit to that. And you don't have exposure to the real-life best practices. You can find it on their own. But exposure to learning is limited. And this situation means we can also create a legacy code. And that is exactly what happened in my case, because I was using statistical software for developing an application, not an optimal solution. However, as I mentioned, this project was kind of successful. I mean, it looked successful. So what is the natural, journey here? If it works, if new features are shipped, probably management would like to put more human resources to work on the project. And we were not IT specialists, we're economists, so everybody thought, okay, doubling the resources, the human resources working behind the project would mean doubling the effects. Is that true? Of course, not in that case, because, let me remind you, we didn't even have version control system. So we were basically overwriting each other's code. You may ask, okay, so how did you merge your code? I cannot believe it right now, but we literally did Ctrl-C and Ctrl-V at the beginning, which meant we forgot some lines, so new features were not working, and the old features were sometimes broken as well because of overriding some lines by accident. And no version control hosting system meant that it was really difficult to debug, of course. And here, let me share a story with you, like to illustrate what kind of management problem can happen in that situation. So one day I had a demo to our client, and I really wanted to show some new features on the map, because this data science model was about plotting some features into the map. And surprisingly, I used the functionality, nothing appeared on the screen. Of course, I got very stressed during the demo and also afterwards, because debugging without version control hosting system was a nightmare. And I wouldn't debug it either way, because it turned out the problem was not in the code. Problem was that basically shape files underlying the special features on the map were moved to different location. And of course, they did not move themselves, but my colleague, my co-developer, decided to spontaneously do some out of the backlog cleaning. And I wish I could tell you I handled this situation with maturity and class, but it's not what happened. Our discussion very quickly started to resemble pointing fingers at each other. And my manager noticed it, and he gave us 15 minutes to come up with a productive solution to ensure this kind of situation does not happen again. Because basically we were discussing, let's call it that way, and fruitfully, and application was still not working. So thanks God for my Googling, because I already knew what Git is, and I wanted to implement that in the past. But because we were actually not very technical team of economists, people knew, okay, this would be new tool, everybody needs to learn that, why is this for, nobody needs it. But this situation showed actually that this kind of code is not manageable anymore, and thankfully 15 minutes was enough to convince my co-developer who did this cleaning that it is a good idea. So this situation actually learned me that tensions in the team, because I don't want to call it conflict, are not about, just two individuals do not want to cooperate. It's more about having a fear of making a mistake or being exposed that we are not competent enough, so like classic imposter syndrome. And it learned me, what it learned me is that it's the best to rather focus on the problem in this kind of situation to try, even though that's of course emotional, to try to look how can we improve our teamwork in that situation. And I would lie to you if I told you that it solved all of our problems, but what I can assure you, I will not exaggerate, this situation did not happen again, and tensions between us were significantly diminished. So new features started being shipped again. Everything is working, of course, my team had some learning around Git, but it was working. And what can go wrong right now, next stop on our journey? So if everything works, probably we want to boast and show the product to our client in another way rather than Agata traveling with her laptop and showing it to everybody. So the solution I came up with was, of course, like now it's kind of obvious, but we set up virtual machine in the cloud. However, what turned out that it was a real nightmare to ensure that configuration of this machine is the same as our configuration, and also ensuring versions between developers, the packages version are the same. While my colleagues were developing, I was so frustrated to fix all these issues rather than focusing on the delivering business value and code. And what was the solution here? Again, after some Googling, and my team was more enthusiastic right now towards my new, let's say, innovative solutions, because Git worked previously. And that is funny because the way I advertised Docker to my team was, we just take code and we just take all the dependencies and we kind of compress it to one quote-unquote file. So of course that's a metaphor, I would say, for Docker image and later Docker container. And this was a success story because nobody objected in that situation. So maybe kind of boring, let me give you another one. Another workplace I worked later was had implemented this division for developers team as well as operations team. It happens very often. And operations team were kind of innovative and they wanted to implement this kind of functionality to containerize everything. But my colleague had big problems determining, from getting this information from developers, what kind of packages are they using, what kind of dependencies are there. It was not clear whether they did not know or were not willing to share. And eventually one developer colleague told, but why do you even need it? That is an extra effort. It works on my machine, so why? And here is the statement I would like to make. So even though I'm telling you these stories, it's still around CI/CD, and how I think about it is just, in this situation, we need to go and look beyond the fact that it is working on your machine. I mean, it is cool that it works on your machine. I was also happy when I built this data science model and dashboard, but yeah, it is basically about robustness and working in each and every situation, and Docker can ensure you that. And at that point, we had development environment and quasi-production environment. If you want to test your changes, you're welcome to build more environments. And it is very tempting, actually, sometimes to make some cost savings on other environments than production. But it may actually cost you a lot more than this saved money. And for now, let me switch to talking about other people's experience, not mine in particular. Once my friend asked me what this whole CI/CD system is, and I sent him few articles. He read it and he told me, okay, Agata, now I understand why my developer colleague does not like the operations team. And I wanted to know more, like why. He showed me a message, his developer colleague, written to the whole company, tagging everybody, CEO, CTO, and the first lines of the message stated, "It is not our fault that application does not work in production environment." So already these first lines showed that this turned into kind of pointing fingers because they were put in defensive position. So probably the imaginary finger of blame was pointed on them earlier. And they claimed, but it works on dev environment, on staging, and production is configured differently. We don't know how, Ops team does not want to tell us how, and we're not able to debug because we don't have access to production environment. So of course, rabbit hole of debugging. They even propose some workarounds, but it will be still debugging blindly, and not a very efficient solution. I don't think that's the best idea, that developers team need to figure out some workarounds on operations team not being able to ship requirements. And that is all instead of developers just delivering business value. So very demotivating actually for them and for the team. That is why you probably don't want to make this cost savings. And this situation very resembled to me the situation I had before with my former colleague. It was like we were pointing fingers and nothing was working, not very optimal solution. And if you know 12-factor application, so principles developed by Heroku's Adam Wiggins in 2011, one of them is exactly telling us about environments should be configured in the same way, because otherwise we are facing lots of risks. Okay, we have everything in place, even these environments configured in a similar way. But what can happen in most of cases when we have separation of developers and operations team is like in this scenario, and it doesn't have to be a model. It can be an application, it can be everything, is that developer needs to wait for another team to deploy. That is why at one point in one of our previous teams, me and my colleague decided to join forces and let's say enroll developers to speed up deployments, enroll developers on that board. So we just built a bash script, and all was needed is just to run it. It was documented, in my opinion, well, but apparently not, because some of the developer colleagues were still reluctant even to run that bash script. And when we asked why, they were like, oh, because we need to touch the production, it's scary, Docker is scary. So you may think, okay, maybe you don't want developers to fight on spawning infrastructure instead of delivering their solutions. So how to solve that situation? Actually, we can solve it with automation, and that is what CI/CD defined a set of tools is about. Basically, you can have your deployments ready in one click, or even more automated on pull request or merge to your main branch. And when you have your deployments and even maybe tests automated like this, you might think, okay, that's maybe too costly, but actually we have like maximally reduced risk of conflicts in the code as well as in the team in that situation. And what is even more important, reduced risk of outage, because all the tests are happening in CI/CD stage, and finally rollbacks are made so much easier. And yeah, team's well-being is finally better, less stressed, I would say. And I still didn't put a definition here, but this is CI/CD pipeline, so something like production line. And yeah, you probably know lots about it, but we commit as often as possible, then continuous integration runs some tests, and continuous deployment is all about automatically deploying to your environment. So what is tools and practices for in that situation? I was trying to show you on my example that it is not like, appearing in blank space, but it is actually the solution of reducing conflicts in your team and reducing stress finally. If, developers and everybody is less stressed, we can just work more efficiently. That's not a mystery. But how I would like to think about it, it's not even a set of tools and practices like it is usually defined, but more like a mindset of focusing on continuous improvement and finding new ways of making our team work better. Because I personally believe, and I think that's because of all this situation, is that tools and procedures should not be goal itself, but just solution to the problem and serving people instead of themselves per se. Some tools, CI/CD tools, no time to talk about all of them, of course. If you're interested, I will refer to one blog post on our Scale Factory blog. But I think it is particularly interesting to look into these CI/CD pipelines which are hosted in the cloud and allowing for integration with your version control system. And you may think, okay, right now we know everything. What else is needed? We can go home. But as I mentioned, the fun here in this DevOps journey is about finding new ways of improving your teamwork. So maybe it will not apply to each and every situation, but I was personally fascinated by one solution right now in my current job built for one of our clients who had this following use case. They ship their features very often. Features were kind of complex and CI/CD system was not enough. Of course, also QA team needed to test it. But testing by QA is sometimes more expensive rather than initial tests by developers, right? For developers to actually see their code in action to visualize. And you may say, okay, but this is, what test environment is about. But what if we ship really a lot and there is a queue to our test environment? How to deal with that problem? I think a good idea will be to focus on something like ephemeral environments by isolating particular stream of work. And the most natural way to do that is, I think, basing on branch. Because, as I mentioned, most of CI/CDs are based on your version control system, and branch is basic unit of work in your code. That is why it would be cool to, for example, automatically, on creating a new feature, create an ephemeral environment which would automatically deploy their changes, and then it could be easily destroyed. And you may say, okay, but it's super complex and we wanted to reduce work to our developers. And I would say, okay, but we can do all of it just by one click or by connecting it to your version control system. So then you still might have doubts and say, okay, but isn't it like we are, departing from branches? Like we want to move from Git flow, probably it's too complicated, to trunk-based development. But the truth is, even in trunk-based development, you rarely have this first scenario, like pushing your code straight to the main branch. You probably don't want it very often. You still want to have some isolated streams of work which can be tested before pushing to the ultimate source of truth. But the key is they need to be short-lived, as you can see, and as I think it's reasonable. So the case here is not about departing from branch, but just making it short-lived, and that corresponds well to ephemeral environments, in my opinion. And yeah, maybe that's not for every use case, because of course it's costly, but it can be super helpful with testing. And how to spawn this infrastructure, as I said, on one click or even push, a very helpful thing would be infrastructure as a code here. And in my example, because I'm going to show you some demo, that's actually what I will be using here. So let's jump to the demo right now, and am I able to jump? Right, so this is the repository with a demo, and let me take you on a journey through directories which are here. First one is it is like a default name for GitHub Actions, which is basically GitHub CI/CD, and this is where the magic will happen. I have a directory, hello world, with the application, and then two directories with infrastructure defined by Terraform. First, it will be, of course, all of your environments may be fully separated, but the convention I wanted to show here, we can even have some piece of infrastructure shared across environments. And then workload is just environment specific. And let me maybe start with showing you the application. It can really be anything, but for the purpose of demo, I'm just using simple Docker image from Python, which is running server.py. And we probably want to know, okay, I have some lag here, but I will try to manage. What is in the server.py? Just simple hello world message. And then shared infrastructure. This is not really a presentation about Terraform, but just as an example. I have virtual private cloud here. By the way, I'm using AWS provider. I didn't mention that before. I have subnets, public and private, and internet gateway and NAT gateway here, but that is just an example. I can have anything. And in workload, so environment specific, I'm deploying my application using Elastic Container Service, so basically serverless containers on AWS and putting them behind load balancer. Other files are just like helpers. I'm defining logging and security groups here. And I told, okay, that is not really about Terraform, but I would like to show you some caveats for you how to, to know how to deploy it for your needs. And one thing which is worth underlining, you need to have names defined per environment. You really cannot have the same names like in shared infrastructure because it will overlap. That is why I parameterize it using variable environment. And you may ask, okay, but how do we plug it? And that is actually where GitHub Actions will come in place. And just because I have a small lag, it is cumbersome. But let me jump to the actions right now. I can deploy shared infrastructure. And this could be just on a push, for example, to the branch, but for purposes of demo, I just have a button here, run workflow. And the same for environment-specific infrastructure. But here, I choose a branch where to deploy from. And because it is taking like 3 minutes, I deployed this environment-specific infrastructure before my talk. And I would like to show you how more or less that looks like. Okay, so this is probably you don't see, but this address is demo lb test. And the second one will be with dev in their name. So, okay, maybe it's very simple and maybe it's the same, but later I hope it will be a little bit different when we deploy it. But it can really be anything. That's just a skeleton. Of course, by analogy, we need to have destroy infrastructure because it's about to be ephemeral. And an action for deploying application is also by choosing a specific branch and clicking the button. So let me try to make some change in it, just to see it's working. Like just to see I have not deployed everything before the talk. So here, let me check on which branch I am. I am still on the test, so therefore I will type here a different message. So for example, from test environment. And all I need to do is to commit these changes. And push them to my branch. Of course, to the test one. And that could be it, because I could have defined it deploying in an automatic way. But in the demo, I'm clicking a button. And as you can see, it also takes like 3 minutes. We still have these 3 minutes. So let me take you right now through the code of actions, because I think that is something what is the most interesting here. And first action, deploy shared infrastructure. So that is actually how GitHub action look like. This is a little bit laggy, so maybe I will use, VCS code. That would be probably better. I hope you can see something. So build shared infrastructure. Here I'm defining on what trigger do I want my workflow to run. And here I can define that it, for example, needs to be pull or merge to a specific branch. I'm just using workflow dispatch, is just deploying on the button. And then I'm configuring steps to deploy my shared infrastructure. I'm configuring AWS credentials by assuming a role for AWS to be able to deploy the resources. Checking out the code, and something very standard for Terraform, init, plan, and apply. So kind of boring, but with auto approve because yeah, we don't want to be prompted to type yes because it is an automatic action. There will be nobody to type yes on the other side. But where it gets more interesting is environment specific workload. What are the differences here? Because it also consists of AWS credentials, checkout, init, and other Terraform steps. But I'm just taking the name of the branch from the GitHub. Let's make it bigger. I'm just improvising here. Okay. Yeah, so branch name from GitHub, and then where I would pass it, actually that is in our apply step. This is the variable you might remember when I define different names for different resources for different environments. And that is one thing I need to account for. And another place where I'm passing that branch name is in key to the Terraform state. State is like a store of configuration of Terraform resources. And because I don't want to override my resources, I need to keep environment-specific state separate. And the thing is, in Terraform, you cannot really make it a variable in Terraform code itself. That is why you need to do this dynamic backend configuration, meaning to take it out to your, for example, GitHub action, and yeah, just define backend config with init. I won't really go through deploy action because that's not a talk about ECS and so on. But showing you another trick. I can also take GitHub, like commit SHA from GitHub in the same way I took a branch name. And why it would be useful for me? It would be useful because I can build an uniquely named image with Docker and push it to my ECR repository. And I can use that as a name, basically a variable for my tag in Docker. So, yeah, I think that is the most caveats you need to know, building this kind of architecture. Let us see how is our test environment. And thankfully, it worked with live demo. You never know, but I try to keep it simple. And that concludes our demo. As I don't have much time, probably let me jump to key takeaways. And what I would like you to remember from this talk is just, I don't think CI/CD is just a simple set of tools and practices, because of course it is, but firstly, it's like more about a specific mindset and yeah, facilitating our teamwork and using these tools and procedures as a means to avoiding conflicts as well as avoiding making mistakes. I believe that's what DevOps is about, and generally CI/CD, which is beautiful because it makes it not the goal itself, but a journey, a process. And what neurobiologists are saying is that actually endorphins are firing not when we reach the goal, but when we are struggling towards it. That is why I think it's a good information in this context. And at the end, I want to underline that actually it was a talk about mistakes, about my mistakes, so I was completely open with you. And I think we should not be afraid of making mistakes. So my manifesto at the end is to go and make mistakes. That is how we learn, but not unconditionally. And I will use words of my former manager, the same who gave us 15 minutes to come up with a solution. It is okay if you make a mistake once or maybe twice, but if you repeat the same mistake more times, that means you're probably not learning from it. So I think that is one condition we need to have in mind. And I think that is everything. I also have some cost-benefit analysis if like somebody will be more convinced with pure economics rather than these people thinks. So even though maybe configuring environments in different ways seem like a cool cost saving, in fact it like puts you in a risk of spending more in longer run. For example, imagine all these outages and developers trying to go into rabbit hole of debugging and blaming each other, as we already have seen, while the application is still not working, not a very optimal solution. And if it happens with automation and similar environments, all you need to do is just roll back, which is easier if you have unique tags, for example, in Docker, and maybe even blue-green deployments. So yeah, I will leave you with that 2 sets of advantages of CI/CD. Thank you very much for your attention.
It's not a question. It's and it's about the journey, not the automation. I want to encourage everyone here to build your own developer communities inside your company. So I know that, I don't know how to spell it, that National Nederlanden is a big company. And I don't know if whether you already have this inside your company. You have your own or internal developer community. But if you go to another company and there is no such a thing, I encourage you to build that developer community inside. So my company is a huge company. We have developers all around the world. And sometimes they all doing different things. And you have, well, you say discussing with your colleagues. This kind of thing happens. It's part of the journey. But sometimes you need to find information, knowledge in other developers, people, person inside the company. So again, if you don't have those developer communities inside your company, you can build it. So go for it. And it's not for you, of course, it's for everyone here.
Like encouragement. Yeah, I think that is a good idea. And it also requires setting this mindset to more teamwork oriented, I believe, and realizing that we're playing in one team rather than blaming each other sometimes. So yeah, good remark. Thank you for that. Another question? Yeah.
Very fast, and it's actually a question. Thank you for your talk, first of all. It was really heartwarming to see you realize like everything, and you like got sensitive to those problems, because most people resist these changes. So it was actually amazing, and thank you very much. It was really, really nice to hear that. How long did it take you, the whole journey? Because I don't know if you mentioned, but it must have been a long journey, right?
It depends on which stage. If you mean all these stages, and when I actually became DevOps, I would say it was like 3 years, but I was working a lot for lots of startup companies, and that, like several at a time, and that's actually how you learn, sometimes hard way, but you're experimenting. So yeah, I think that was it.
Well, thank you.
Thank you as well for your question, and thank you for your attention. It was a pleasure.